So question 2 of the mechanics paper was this pulley. Just pause the video if you want to have a chance to read the information that it gives you. So I've redrawn my diagram over here just so I can do my working underneath and also annotate the diagram. So I've got my reaction force going up here. That's stopping this particle from falling through the plane. So it's perpendicular to the plane. I've got tension going that way away from the particle and tension going that way away from that particle. Because it's a light string, those tensions are equal. I've got my weights coming down here, 3 mg and mg, and my friction will be moving that way against the direction of motion. So if this is heavier, it's going to move that way. Mu is a 6, as it said in the question, and it said that tan of alpha is equal to 3/4. So if I draw a little right angled triangle with alpha, I know that the opposite over the adjacent is 3/4, 3/4, must be a 3/4 triangle. So cos of alpha is going to be 4/5 adjacent over hypotenuse, and sine of alpha is going to be 3/5 opposite over hypotenuse. They might come in handy later. It might be nice to have them in exact form. So I also I think I'm going to need it later. I'm going to need to break down this force here into its component parts. So this is the only force that isn't perpendicular or parallel to the plane or coming off this M, acting on this M. So if I break it down like that, then that angle there would be alpha. Sorry, it's quite small. This force here would be 3 mg cos alpha, and this force here would be 3 mg sine alpha. Right, so part A of the question asked me to write down an equation of motion for A. So I'm going to need to use F equals ma, and I'm just thinking about this particle here, particle A. This is particle B over here. So F is the resultant force. So the resultant force there going in the direction of motion. In the direction of motion, I've got 3 mg sine alpha. And then acting in the opposite direction, I have T going that way, so I'm going to have to take away T. I've also got friction going that way. I tend to just use FR for friction. And that equals MA, so that the mass of that is 3m, and the acceleration is A. Okay, so that's part A done. For part B, it wants me to show the acceleration of A is 1/10 g. Okay, so I'm in the end going to need to use F equals ma. I'll probably use that for the whole system in the end, but before I can do that, I'm going to need to find what friction is, and friction is at its maximum because the particle is moving, and that means that I'm going to need that it's going to be equal to mu r, which means I'm going to need to find r. So I'm going to need to resolve perpendicular to the plane. So really important to say what I'm doing. So going up away from the plane in a perpendicular direction, I've got r, and that is equal to 3 mg cos alpha. So just filling in the things that I know that cos alpha is 4/5. and 3 times 4/5 is 12/5 mg. So R is 12/5 mg. So I know that F max, friction is at its maximum, so it's equal to mu R. Now mu is a sixth, and I've just found that R is 12/5 mg. So if I multiply those fractions together, I get 2/5 mg for friction. And now, because I'm trying to find the acceleration of A, I'm going to use F equals ma. I'm going to use it on the whole system. Okay, we could just do it for one part, but I'm going to do it for the whole thing. We could actually just use it for B, but I think it would be nicer to do it for the whole system. So my resultant force, I've got 3 mg sine alpha going in this direction. I've got 2/5 mg, which is the friction acting in the other direction. And I've got mg, this force here, acting in this direction. And that's equal to my mass times my acceleration, so total mass is 4m times the acceleration. Now, first thing I can spot there is that I've got m's in everything, so I'm going to cancel those. Sine alpha is 3/5, so let's put that in as we go as well. So I've got an expression just with G and A. So if I simplify this, I end up with 2/5 G equals 4A, and then if I divide by 4, A is 1/10 G, which is what I was hoping it would be from the question. Part C of the question asks me to sketch a velocity time graph for the motion of B from the instant when A is released from rest to just before it reaches the pulley. And part D says, in reality, the string is not light. State how this would affect the work in part B. So my velocity time graph is actually going to be quite simple. Just going to be a straight line. And that's because the acceleration is constant. Okay, so that's a really important fact for this. And then for part D, if the string wasn't light, then the tension acting at A would not equal the tension on B.